Hello everyone, welcome to Spring Summer 2024. I'm Sara Van Pee, a fashion editor and a member of the Première Vision fashion team, and we're really excited to present the latest sustainable innovations for fashion to you today. Before we start, just a quick reminder, it's forbidden to take pictures during this presentation, but you'll be able to stream it on our website really soon. So one of the most important factors in sustainability is sourcing, because a product's impact comes in large part down to its materials. And when sourcing, before looking at products and their specificities, the single most important thing to take into consideration is environmental management, meaning the actions that companies take not just to reduce the impact of a specific product, but throughout their whole business. Environmental management has to be taken into account along the entire value chain, from the raw material to a product's end of life. It is assessed on the following issues: chemical management, energy efficiency and related CO2 emissions, water consumption and effluent treatments, and waste management. Let's start with chemical management. Textiles and leathers use a lot of chemicals to transform products, to give them a new look, a new feel, a special performance. And the dosage and the chemical ingredients have to be precisely gauged to avoid harmful effects. So chemicals have to be evaluated for their gas emissions and for how toxic they might be for the wastewater or the finished product. Different regulations and certifications exist. In Europe, we have the REACH regulation, but there are other initiatives such as Ecotech's Eco-Passport, Zero Discharge of Hazardous Chemicals, Blue Sign, or the Leather Working Group. Energy is linked both to the use of fossil resources and to the emission of greenhouse gas. To lower our energy consumption, different things can be done. There's evaluating our energy consumption and choosing efficient energy processes. There's favoring renewable energies and establishing a maintenance strategy, ensuring the longevity of machines in their optimal conditions. Water is another key issue, especially during the dyeing, finishing, and tanning. Water use creates two challenges. There's the consumption of fresh water and the water pollution. According to the UN, fashion is responsible for 20% of global wastewater. To reduce this, we need to develop technologies that combine efficiency and low water consumption, but also effluent management, filtration, treatment, and the purification of sludge and wastewater through settling tanks and biochemical treatments. Now, let's turn to waste management and how fashion is reducing its waste. There's the reduction of co-products and offcuts during the manufacturing process. There's increasing technologies to value those residues and set up circular systems. And there's securing waste disposal with safe elimination of non-reusable byproducts or remaining toxic substances. Now, let's move on to traceability. It's a fundamental concept and the key to social and environmental responsibility across the value chain. Traceability allows us to meet regulatory standards, showing respect for good social and environmental practices, as well as animal welfare. It helps to establish reliable diagnosis of our operations and also to communicate clear and consolidated data. In fabrics, traceability is gaining momentum, from certified cellulosic fibers from sustainably managed forests to traceable European linen or GOTS-certified materials that are traceable throughout the supply chain. Organic cotton was the first material identified as sustainable, but today qualities are evolving. Aside from essential products, long staple qualities are now adapted to a high-end offer. Cotton from regenerative agriculture is different than organic cotton. Here the goals are to optimize carbon capture in the soil, to restore soil fertility, to improve water retention, and to conserve biodiversity. Here we have a certified European linen. It is grown in a region that spans from northern France to Belgium, all the way through the Netherlands. And its excellent quality is due to a unique combination of a natural damp ocean climate, a rich soil, and experienced flax growers with specific cultivation practices. Two major certifications attest of its high quality value. There's European flax for premium flax grown in Western Europe without GMOs or irrigation. And there's Masters of Linen, which certifies all stages from the field to the yarn to the fabric. If you don't choose a certified European linen, you have another option, which is organic linen. It guarantees no GMO, crop rotation, and the absence of toxic chemicals at the farming and processing stages. Organic silk is also more present this season. It's sometimes harder to understand the meaning of organic when it comes to an animal fiber. So for silk, it guarantees that the silkworms are fed with leaves from organically grown mulberry trees. And if the finished material is GOT certified, it also means that no toxic chemicals were used during the processing stages. Now, let's move on to the artificial fibers. The use of wood pulp to make viscose has been linked to deforestation. Now, with FSC certified viscose, traceability ensures sustainably managed forests. FSC requirements are to promote the conservation and restoration of forests, to conserve biodiversity, to respect the rights of workers and indigenous people, and to create economically viable added value for local communities. EcoVero is one such viscose that is made from sustainably managed forests and with a certified traceability program. Producing EcoVero takes up to 50% less water and emits 50% less CO2 than conventional viscose. It has been certified by the EU Eco-label for environmental excellence, and this applies to the entire life cycle from raw material extraction to production, distribution, and disposal. This season, it's available in a wide variety of qualities. Naya is another cellulosic fiber with FSC and PEFC certifications. It can be turned into a range of acetate fibers and filaments with a low carbon impact and water savings. And the production is a closed loop. Still, in the artificial fibers, we have C-Cell, which is made from sustainably managed wood pulp, and it's mixed with an algae. It has a low chemical impact thanks to lyocell transformation processes, reusing the non-toxic solvents used. Now let's move on to leather. Here, traceability involves all stages, from breeding to the finishing processes, collecting data from related industries, because of course leather is very linked to the food industry, and obtaining data about the raw hides for information on breeding conditions and animal welfare. The leather industry is constantly making improvements to go beyond existing regulations. The goal is to monitor the entire chain of production, from breeding to the slaughterhouse to the finished products. Best practices can be audited and certified via ISO 14001, which is the reference standard for environmental management, the Leather Working Group, and the eCheck Institute for Quality Certification for the leather sector. Here we have an example of a skin that is fully traceable. It's a skin made from organic German buffaloes from Albuffel. Another example here from a French tannery committed to using only French-made leather and respecting animal welfare. They buy the raw materials in short circuits from the same suppliers who have been their partners for decades. So while some tanneries do every step of the transformation process, others work with wet blue hides. These are skins that have been already through a first chrome tanning. So here we have a Torillon leather from a tannery that works with wet blue hides, but they are certified by the Leather Working Group. Another way to look at traceability for leather is the tannins. This leather is made by a tannery that is specialized in vegetable tanning, and the tannins used, Cabraccio and Mimosa, are fully traceable and FSC certified. Now let's turn to accessories. It is crucial to integrate them in your quest for sustainable sourcing and eco-design. They play an important role in the impacts of the final product. And because they include so many different materials and know-hows, the issue is sometimes difficult to navigate. In terms of traceability, FSC-certified wood can also be an option here for components like hang tags and J-crayons. They come in various certifications. There's FSC 100%, which means that it's virgin fibers from FSC-certified forests. There's FSC recycled, which means recycled wood pulp from pre-consumer or post-consumer origin. And FSC mixed, which is a mix of both. Sustainable linens are also found in the offer for elements such as zips or ribbons. Traceability can also guarantee a high-quality origin. For example, here we have long staple fibers of Egyptian cotton. But beyond origins, know-hows can also be highlighted, such as France Terre Textile, which means that a minimum of 75% of the manufacturing stages happened in France with a high level of quality. And there's Entreprise du Patrimoine Vivant, Living Heritage Company, which highlights French excellence and rare artisanal and industrial know-how. Now, let's focus on the diversification of raw materials. It's really accelerating everywhere from fibers to tannins to accessories. And diversifying raw materials serves a variety of purposes because it reduces the current stress on supplies and it stops the pressure on the same conventional materials. This ensures a better environmental footprint and new design opportunities found in the behaviors of these new materials. For fabrics this season, we see a diversification of fibers, with more and more linen and hemp in the offer. There's also more and more bio-based synthetics to free us from fossil resources, and new alternative natural resources from the agri-food industry waste transformed into new generation fibers. Let's start with hemp. It has a number of sustainable qualities. It doesn't need a lot of water. It is a carbon sink and it restores soil. And all this encourages suppliers to diversify its use thanks to different blends. Here, for example, it's mixed with organic cotton. But we also see the rise of beautiful 100% hemp compositions with handles that are much more delicate and smooth than they used to be. Nettle is a long fiber that is extracted from the stem of the plant. It grows really quickly, allowing up to 5 harvests a year, and it requires little water. It also has good resistance properties, making it an asset for everyday casual knits. Kapok is a drought-resistant crop, needing minimal water, and it also has interesting properties such as moisture management, temperature regulation, and it's naturally water repellent. Responsible bast fibers, such as flax and hemp, are also available in cellulosic blends, like Lyocell and Ecovero. The result is a handle that is both round and fluid with increased resistance, and a visual with discrete slub patterns. The abaca fiber comes from a specific kind of banana tree. It can be grown with rainwater alone, without pesticides or fertilizers, and it is developed in blends for added stiffness and resistance. But bananas aren't the only fruit providing new fibers. We also have new cellulosics derived from oranges. This high-quality cellulose is extracted from the remains of the juice industry. Recycling cellulose, such as this one, is a way to replace virgin cellulosic resources, and that's a circular approach that lowers the environmental footprint. AgraLoop specializes in transforming bananas, pineapple, hemp, and flax residues from the agri-food industry with a clean chemical process to refine the cellulose found within them. It's a completely circular production. The water is recycled. The only effluents are organic amendments returned to the farmers to regenerate the soil, and byproducts are turned into paper, biocomposites, or bioenergy. Now, let's turn to raw material diversification for synthetic fabrics. Here we see a rise of bio-based polyamides for technical knits, and this new generation of synthetics is derived from the biomass, and it drastically reduces the use of fossil-based content. Here we have Essential, a biosourced polyamide, and 55% comes from agricultural waste. PLA is a bio-based fiber formed by the polymerization of lactide extracted from the agri-waste, like corn, sugarcane, beet, or cassava, and it requires no fossil resources. And speaking of corn, it can also be turned into Solotex, which is an innovative high-elasticity fiber which can be used to make bi-stretch fabrics. Stretch is actually a complicated subject. Aside from mechanical stretch, which you can get with crepe yarns, for example, we still rely on elastane. The first challenge with elastane is how to obtain it without using fossil resources. Here we have two solutions, with bio-based elastane on the left and recycled elastane on the right. The second challenge with elastane is the end of life of the product. Here we have an example of a Roika V550 elastane. Its biodegradability is optimized and it doesn't release toxic substances into the environment as it decomposes. Of course, as always with biodegradability, you have to take into account the product's entire composition. Here it's mixed with sea cell, which also has enhanced biodegradable qualities. For leather, diversification is more about the tanning processes, meaning less chrome tanning, which still constitutes 80% of global leather production, more chrome-free and metal-free tanning, and for vegetable tanning, using tannins derived from other resources than the traditional quebracho, mimosa, and chestnut. Let's start with alternative vegetable tannins. Here we have a round and supple cow leather that is tanned with rhubarb roots. Growing, extracting, and processing the tannins all takes place in Germany in a short circuit, along with the leather tanning and finishing. And the tannery is self-sufficient in terms of its energy production. The latest developments in vegetable tannings allow for the creation of vibrant acid colors, but also more pale colors like this one. Here we have a very light sea green shade on a matte and wrinkled lamb leather. Aside from beautiful colors, these new formulations also allow new behaviors. They are closer to the versatile characteristics of chrome, with soft and round hands. They also offer the possibility to have fine supports for the development of soft and supple leathers for ready-to-wear. Moving on to metal-free tanning. Vegetable tannings, which we just discussed, doesn't require chrome or any other metals. But the metal-free family also includes synthetic tanning. And more these two techniques are mixed to obtain greater versatility. One of the great advantages of metal-free tanning is that the first tanning stage, called wet white, lends a true luminosity to the skins. This allows the production of bright whites on any kind of hide, whether full grain or here on a sheepskin. The goal with metal-free tanning is to achieve the same qualities as chrome-tanned leather: density, roundness, suppleness, resistance to abrasion. Here we have skins that went through a first metal-free tanning to have a softness and a white base, and then a second vegetable tanning to add some stiffness. These white bases allow the creation of beautiful light tones, like this pastel green, that would be impossible to create with a chrome tanning. Aside from metal-free, another alternative to conventional chrome is chrome-free tanning. This method does use metals, such as aluminum, but no heavy metals. It has similar characteristics to conventional chrome tanning, like resistance to traction and abrasion, a good dye affinity, and allowing intense shade with no need for repigmentation. For accessories as well, we see a diversification of raw materials. Hemp and nettle are gaining popularity in components here as well. They have similar assets with minimal water input, resistant fibers for more longevity, and their medium to long fibers can be used for zips and buttons, and their co-products can be used for papers or composite materials. For components, there is a rise in bio-based materials to reduce reliance on petrochemical resources. Resins can be made from cornstarch, castor oil, sugarcane residues, apples, and grapes. And different certifications exist, like OK Bio-Based, to attest the content and percentage of biomass. Dyeing and finishing are known to be among the most impactful transformation stages in the fashion industry. They combine water usage, the use of chemical substances, a substantial amount of effluents to treat, and they're very energy intensive. However, we see the rise of new technologies and machines that are emerging to solve these issues. In fabrics, several solutions are available to lower the impact of dyeing and finishing. There's retaining the natural color of the fiber, using efficient processes, exploring new pigments that are made from textile waste, exploring biofabrication based on cutting-edge bioengineering technologies. Here we have an example of an undyed fabric. It uses the natural color of the cotton fiber. Some naturally colored variety exists, growing in pink, in brown, and in green, and they retain their original shade over time. Here we have a recycled fabric that has not been bleached and overdyed. The used textiles, here it was most likely denim, are sorted by color for mechanical recycling, and the result is in batches that mix their initial shades. We also see the rise of new waterless processes. These are specific technologies where the color is fixed at the heart of the fiber before spinning, requiring less dye consumption. Innovation also comes in the form of black pigments, known to be among the most difficult to obtain. This eco-black coating is made from FSC-certified wood byproducts. The manufacturing process is a closed-loop system with a zero-waste approach. Other new vegetable dyes come from a circular approach using food waste. There's coffee, rooibos, or here it's matcha tea. In natural dyes, those are dyes that are made with plants or fruits, new techniques are developing. They offer resistant colors, uniform piece dyes in the low to cold temperature processes, and all that without the toxic mordants. And these colors are available for natural plant and animal fibers or cellulosics. Now let's turn to finishings. We now have natural options providing a way to achieve water-repellent properties, like this olive oil finish on an organic cotton. For bio-based synthetics, the goal is to offer a finishing also derived from the biomass. New membranes are now available in polyurethane formulated with castor oil, soybean oil, or sunflower oil, and they have the same waterproof, wind resistance, and breathable properties. Leather faces challenges when it comes to dyeing and finishing as well. Some interesting alternatives are simplifying the process. For example, there's using the natural color of the Bazaine leather. There's using natural extracts to color the hides, and using solvent-free finishings to ensure chemical safety. Bazaine leather is created with a vegetable tanning and retanning and no finishing. Each vegetable essence creates its own handle from supple to firm in specific shades. So here we have Cabracho, which is the reddened tone, Acacia, which is the light tone, and Mimosa, which is the rosy tone. Here we have another vegetable tanned leather. The second tanning is done using grape residues from the wine industry. And they color the skin during the same operation, so that avoids the additional dyeing step, which simplifies the process. Finishings are also evolving into solvent-free, water-based versions. Here we have an olive-tanned leather with a solvent-free finish, which makes the final product safe and hypoallergenic. These low-impact finishes can be found with different effects. On the left, we have a varnished effect with a solvent-free, water-based finishing. And on the right, we have a pull-up effect with a vegetable wax finishing. For components, the goal is to responsibly manage the chemicals. Here, for example, we have sewing yarns or zips with lyocell tape made with non-toxic solvents. There's a silicone transfer, labels, and zips that comply with the JRS criteria for recycled products or GOTS for organic products. And there's solvent-free, water-based polyurethane coatings. For metal, we are looking for low-impact finishes in alternative to conventional galvanizations. There are sustainable galvanizing processes like physical vapor deposition, which is a metal vapor associated with a benign gas to form a coating. There's also YKK acroplating, a brass plating process with no harmful chemicals, no toxic waste, and it doesn't create sludge. And aside from galvanization, there's also mechanical finishing. You can have a raw shine with polishing, and you can create oxidized effects with only water and heat. After traceability, diversification of raw materials, and dyeing and finishing, let's move on to our last chapter, which is about circularity and recycling. Circularity is one of the major concepts behind sustainable development. The goals are to optimize resources all along the value chain, to have a circular cradle-to-cradle approach rather than a linear cradle-to-grave approach, and to create products with an eye for their end of life. In fabrics, recycled materials are evolving. There's an emergence of recycled linen. There's the rise of circular cellulosics from textile leftovers or agri-food co-products. And circularity also explores biodegradability qualities with specific tests and relevant communication about the required conditions. Let's start with synthetics. Here we have a special PET with enhanced biodegradable qualities. It is mixed with cotton to allow the global biodegradability of the material. Here we have sea-oriented compositions. The idea is to take part in ocean cleaning. Eco-Nil is a polyamide recycled from fishing nets. There's a Sequel marine plastic, which is a mechanically recycled polyester, and 10% comes from marine waste. And there's Seawool, which is a recycled polyester from PET bottles mixed with a crushed oyster shell. Because recycling of synthetics is improving, the recycled products can now deliver technical performances. Coolmax, which is well known, is now also available in a responsible version, which is called Coolmax Eco-Made. Recycled cotton used to have no more than 40% of recycled material in its composition, as the regenerated cotton fiber was too short. But now we have 100% recycled cotton like this one. It mixes mechanically recycled short staple fibers with long staple cotton waste from the spinning process. Another way to recycle cotton is via chemical recycling. Circulose is an innovative material made by recycling discarded cotton textiles using a chemical process to produce new artificial fibers. This new material avoids the use of wood pulp, and it proposes an actual textile-to-textile recycling. And today, this kind of recycling accounts for less than 1% of the fibers produced. Refibra is another cellulose fiber composed of 30% of recycled textiles and of sustainably managed wood cellulose. It is produced in a closed-loop lyocell process. The offer for recycled linen is growing as well. The mechanical process is similar to the one for cotton and for wool. And as linen is already a low-impact fiber, recycling it is a combination of good practices from the first life of the product to the second life. And for linen as well, chemical recycling can create new cellulosics. Here, the former color is retained to avoid re-dyeing the fabric. Luxury materials such as silk are now also available in recycled versions this season. Recycled silk is derived from pre-consumer resources, meaning spinning or weaving residues. And they are as soft and shiny as conventional silk. And when the residues are too short to be respun, it is possible to produce high-end insulation materials. Here, this insulating material is made from recycled camel wool, recycled silk, and recycled polyester. Even fabric finishings can be recycled. Here we have a recycled membrane with functional properties for tech fabrics. So on top of these recycled options, many in the field are now anticipating the end of life of the virgin products. For synthetics, microplastics are a major concern, as they are carried through water and air. There is ongoing research and development to figure out a way to develop synthetics with low rejections. The parameters to consider are the type of fiber, the manufacturing process, and the finishing. There's also a rise of sustainable fantasy developments with embroideries like this one. The pattern is a cotton yarn, and the polyamide tulle has been tested for its biodegradability. Again, here, the entire product has to be taken into account for an enhanced biodegradability. And here we even have recycled sequins. In leather as well, circularity is making its way. Of course, leather is known to be one of the oldest recycling industries, as 98% of leather production is a co-product of the meat industry. But today, tanneries go even further, recycling both tanning substances and leather leftovers. This Italian tannery created a process called Evolo that recycles chrome-tanned waste leather. The solid residue is turned into a liquid solution that can be used for retanning without adding any more chrome. And the production cycle is optimized, saving water and emitting less CO2. Here we have a flexible and abrasion-resistant material made from upcycled leather. This company works with chrome-free leather offcuts. The leathers are ground, mixed with a rubber wood binder, and then embossed, printed, dyed, and coated. This is a new yarn made from leather residues, mixed with lyocell, thermoplastic rubber, and spandex. Accessories play an important role in the end of life of a final product, as they have to be removed from the garments. The goal of eco-design is to obtain a product that is durable and that can be recycled. Different components today take these elements into account, like zips where you can remove the slider, or buttons designed to ease the removal of hard points to optimize recycling. To optimize recyclability, you can also choose a similar composition for the main fabric and the components so that the entire product can be recycled at once. Waste is now being transformed into fancy components, with circular creations coming from crushed leather compressions, vegetable waste or textile scraps to color the paper, and we even have a paper made with an algae from the cleaning of the Venus lagoon. Let's wrap up this presentation with the various tools that Première Vision has developed to help you in your own sustainable sourcing. First, there's the Eco-Innovation Forum, which you can find all the products I just presented and so many other yarns, fabrics, and leathers, and ornamentations and accessories. And there's a fashion desk at your disposal where our sustainability experts can give you personal advice on your sustainable sourcing needs. In this forum and on all the other fashion forums, you will see these pictograms to help you identify a product's sustainable qualities in terms of composition, finishing, energy consumption, and so on. These criteria can also be found in our marketplace, where specific filters can guide you through your online sourcing. And if you want to keep learning about sustainability, you have a lot of material on our online magazine. You'll soon be able to find articles detailing the sustainable product highlights for Spring/Summer 24. But on top of these seasonal articles, we are developing smart keys, which are perennial advices, taking a deep dive into specific topics like traceability, tanning, or microfibers. We also have a monthly podcast dedicated to sustainable fashion. It's called Smart Creation, and it's in English. And we interview experts from all areas of the industry. So with all that being said, it's now time for me to wish you a great time sourcing sustainably here at Première Vision. Thank you so much.